Hi, this is about linear regression, and as usual with my slides, I'm giving you an overall impression of what we're doing before we get into the nitty-gritty on our note sheet, activity sheet. So I'm going to show you some examples of scatter plots and best fit lines. Our first example is fuel efficiency and vehicle weight. So these are images that I just found somewhere. I didn't generate these myself. This one has fuel efficiency on the vertical axis, and that's measured in miles per gallon, mpg. And so what we can see here in this graph, you might be like, duh, this is obvious, but as the vehicle weight increases, as you travel along in this direction, we see that the points overall get lower, which means as vehicle weight increases, fuel efficiency decreases. We have a scattering of dots that are generally trending downwards, and then we have a best fit line over that. I'm going to erase that. The best fit line doesn't perfectly touch all the points, obviously, but it gives us a sense of the overall trend of the points. And so the overall trend is that fuel efficiency decreases as the car gets heavier. Now here's a classic math teacher example. What is the relationship between doing your homework and your grade on a midterm? So this was actual data from a while ago, and it's not as clear as the last scatter plot, but when I asked Google Sheets to generate a trend line, the trend was that the line was going up. So these dots sure don't look like they have a linear relationship. I would prefer to see something like this, where the dots were closer to the line. And what instead we see is that there's a cluster of students who are doing really well on both homework and midterm. And then there's some students are kind of in the middle. And then here's a person who's doing really well on the homework, but badly on the midterm. So it's not really a good linear relationship here. Or we have someone who did really badly on homework. They have like a D or a low C on the homework. And, well, that's about a C on their midterm exam as well. So maybe that's not so surprising. When we have paired data measuring two different quantities, so that's exactly what this is for, is we're measuring how well you did on the homework, and then we're comparing it to how well for each individual did they do on the midterm. Or to go back to the previous example, for each car we measure how much it weighs and what its fuel efficiency is. So you have to measure two different quantities for each individual. From trying to find out if there's a predictable relationship, and then is that relationship linear, because there are other types of correlation possible. Here is another example. Viper. I don't know if where do vipers exist? I kind of think of India for some reason. So snakes, and if we graph the length of a viper and the weight of a viper, then we see that there is a trend that longer snakes are going to be heavier. As the viper length increases, then the viper weight increases. And you might be, again, thinking that's pretty obvious, and it is. But the cool thing is, when we draw the trend line and we get the equation of the trend line, we'll be able to dig in a little deeper into what we learn from that. And we'll learn what this correlation coefficient means as well. So this particular graph shows that as you get older, you can't see as far, according to this data. And I have a trend line provided there. Sign legibility distance in feet. So we'll circle back to this one, but here I'm providing the equation of the best fit line, and the distance is 576 minus 3 times however old you are. As the eruption duration increases, so for longer eruption durations, the waiting time between eruptions also increases at Old Faithful, which is isn't that at Yellowstone? I'm getting my state parks mixed up, but I think that's in Wyoming, isn't it? I did go there once. I think I saw it erupt. I don't think it was terribly impressive that particular time. And it looks like there's a cluster over here where you wait a long time, where the duration of the eruption is longer, but then you end up waiting longer between eruptions. Or if it's a shorter eruption, you don't wait as long. Scatter plot, a negative relation. Okay, so this is a situation where a thing goes down as the horizontal quantity increases, the other quantity decreases. So let's think about this. As the percentage of females in the labor force increases, poverty decreases. The percent of people below the poverty line decreases. So ideally, we want to have a low percentage of people who are living below the poverty line. And getting women into the workforce does appear to help with that. And it almost looks like these dots might represent different states: Wisconsin, Arkansas, and New Mexico. So having more women in the workforce decreases poverty. That could be an overall trend that you see. Sometimes the dots are really linear, and sometimes they're less linear, so we'll be able to measure that as well. And before we dive into linear regression, I just wanted to show you that there is quadratic regression. This is a parabola. I don't know what this data is, but that is another possibility. If your data does not look like a line, you might need to do a different type of regression. We won't be doing that in this class. Sinusoidal regression. A sin x graph goes like this, and you could have data that goes up and down cyclically. This example was provided with the textbook. It could help you determine if an auto mechanic's salary is related to his work experience. Typically, when you gather the data, the thing that you put in for X and Y, well, its Y would depend on X. So out of these two things, the salary and the work experience, what would you say depends on what? Does salary depend on experience, or does experience depend on salary? I would say that salary depends on experience. So put experience in for X and salary for Y. So what you would do is you'd go out and survey a bunch of people. And here's a person with 2 years of experience, write down their salary. 10 years of experience, write down their salary, and so on. That's how you gather your data. And then you plot your points. And X would be years of experience. And Y depends on X. Y would be the salary. And then you plot your points. So that's the person with 2 years of experience, whatever their salary is, and then you get the person with 10 years of experience, and they might have a higher salary, and then you draw your line, and you get a whole bunch of points. And before we find the regression equation, we like to look at our scatter plot first. We can do this on Google Sheets, and I'm going to show you that, but we can also use our graphing calculator. So we enter the data, and then the calculator can give us the best fit line. We graph the scatter plot and the line. Then we can interpret the A value and the B value in the equation. We use the equation to make predictions. I'll have you make some predictions using that equation. And then the calculator will give us our R and R squared, and that will help us to see whether it's a weak or a strong relationship between X and Y. If B is positive, so this is the slope, this is the number that's attached to X, and that tells us whether the line is going up, is flat, or is going down. And I'll dig into what that means a little bit more in this example.